Hello everyone, here is Ali Talabi. Welcome back. This is the second lesson from the fifth module where we're talking about TVM, time value of money. So we talk about lump sum and how we can find the present value and future value of a lump sum. Now in this lesson, we're going to talk about several cash flows. What if you have more than one cash flow and you want to find the present value or the future value of that cash flow? First, we have to be clear that there are two types of equal cash flows. One, it is called annuities. When you have equal amount every period, but the timeline is limited. You're talking about the limited number of periods. We're talking about annuities. So annuities, they have two features: equal amount, equal payments, and for limited period of time. However, if you have equal payments, but we're talking about unlimited number of periods or infinite period, now we're talking about perpetuities. So make sure that you distinguish between annuities and perpetuities. So for the annuities, the examples are very common. So you can talk about mortgage or a loan payment. So when you are buying a car, you have to pay back for 5 years, for 3 years, for 10 years, you need to pay back the loan. Same for the mortgage. So these are examples of annuities. The payments are same for a limited period of time. But when you talk about preferred stocks, usually preferred shareholders, they receive equal payments for unlimited period of times as long as they own the stocks, as long as they live their life. So that's the difference between annuities and perpetuities. So the next question here is how we can find the present value for annuities and perpetuities. So let's start with the annuities. So the present value here is a bit more complicated than what we had for the lump sum. Why? Because the idea here is you need to find the present value of each payment or each cash flow for the limited period of time. If you have just cash flow for 2 years or 3 years or 4 years, it's not that complicated. However, if you have, let's say, 20-year payments, now that's a different story. It's kind of much more difficult. So you can use this formula to calculate the present value. The C here is showing the payment for each period. R is showing the periodic or annual interest rate, and T is showing the number of periods. So for sure, you can use the present value. You can use the formula to find the present value. There are much more straightforward ways to calculate the present value of annuities. Again, my favorite friend here will be the financial calculator. I'm going to explain how to use your financial calculator to find the present value. For now, remember, this is a type of annuity which we call regular or ordinary annuities. We have another type of annuities which is called annuities due, and I'm going to talk about that in a few minutes. So also you can use the formula to calculate the future value. So if your goal here is to find the future value of all these cash payments, so one way will be just find the future value of each individual payment. So you go one by one, and at the end you will add them all. Another easier way is just use the formula. Again, C here is your payment or cash for each period, R is your annual interest rate, and T is your number of periods. So again, we are here assuming the payments either in the present value or future value is starting 1 year from now. So that's what we call ordinary annuities. Now, as I mentioned, there are two types of annuities. One is ordinary annuities. If the payments are happening at the end of each period, remember it's called ordinary or normal annuity. If the payments are happening at the beginning of each period, it's called annuities due. For example, if you're paying your rent at the beginning of each month, that's a kind of annuity due. So let's say you're renting a place for 1 year, you need to pay 12 payments. You will have 12 payments you are paying at the beginning of each month. That's an example for the annuities due. So be careful here. What's the difference? The annuity dues and ordinary annuities are related. How come? So let's look at this example to explain. So in this example, you see we're talking about three equal payments of $4,000. So your PMT is $4,000. Again, I'm using negative sign here because I'm assuming that's the cash payment, cash outflow. So you are paying $4,000 for each year. So you're talking about 3 years or 3 periods. So your N should be 3. So the question here is, if the interest rate is 10% on annual basis, with this payment, how much I will have now? Or in other words, what's the present value of this annuity now? So one way is you can go and discount back all these payments one by one. So you have 3 payments, you need to find the present value of each payment and then add them all to find the present value of this annuity. Again, you're dealing with each payment as a lump sum. So we learned before in the previous lesson how to find the present value of a lump sum. That's one way. The easier way is to use your calculator. Again, I set all these variables. So you have N, you have I per year, you have PMT, and since you're looking for the present value, the future value should be 0. If you're looking for the future value, the present value should be 0. That's how it works in this financial calculator. So again, how we enter the numbers and variables. So you go with the numbers first. My advice here is to start always from the left just to avoid any confusion. Sometimes you enter the number twice, so it might get the different result or change the number. So anyway, so you start with N, which is your number of periods. So it's 3. So you hit 3 as a number. After you hit the 3, you go with the variable. You hit the variable which is N here. So you see in my calculator now I have N equals to 3. The next one is I per year. Again, hit number first. This is 10%. You don't go with 0.1 here in this calculator, BA2 plus. You will use just 10. That's it. And then you hit I per year. So I will have I per year as 10%. I skip PV because I'm looking for that. I don't have it now. The PMT is $4,000 negative. So you enter $4,000 first. So you see on the last row, there is a plus minus button as you see here. So you hit that plus minus. Now it changed to minus $4,000. And then you hit PMT on the third row. Finally, the FV future value is 0. So I hit 0 and then future value. What is the last step? So after entering all these, all the numbers are in the memory of the calculator. So you don't see that all of them here, but they're already in the memory of the calculator. So you hit CPT. That's the first button on the first row. So CPT, and then you go with the present value, which is on the middle of the third row. So when you hit that, you will see that the present value is 9,947. That's exactly the number you see on this slide. So that's your present value of this cash flow. As you expected, the present value of 3 equal payments of $4,000 is less than $12,000. 3 times 4,000 is $12,000, but the present value is 9,947. Why? Because that's the present value. The present value is much less than what you will receive sometime, some money in the future. So that's why we use the term discounting. Actually, you're discounting back all these cash flows. So we learned this is a type of annuity which we call ordinary. However, what if the payments are happening at the beginning of each period? So if that's the case, you will see that you're discounting back for one less period. Why? Because for the first $4,000, it's happening now. You are not discounting that. It's happening now. The value of $4,000 you receive now is $4,000. So you don't need to discount it. However, for the following 2 payments, you need to discount them back for 1 period for the first one and for 2 periods for the second one. So that's why you see the total value of this present value is actually more than the ordinary annuity. Again, why? Because you are discounting back for 1 period less. One last note for calculation. You can also use the financial calculator to calculate the annuities due. How come? First, make sure you change your calculator from the ending payment to the beginning. How come? So these are the steps you need to follow. So hit the second button first. So that's the second. You see here, that's the second. I hit the second, and then payment. The second function is BGN, or beginning. As you see, that's the payment, but on the top it's saying BGN. Okay. Now you see it's showing END, which is ending payment. We want to change that ending to the beginning. Then you need to hit second again, so second again, and you need to hit enter. Again, be careful. That enter you see here, that's what you see on the first row here, enter. When you hit that, you see that END is now changed to BGN, which is the beginning. Now you're done. So you can use the same numbers, same inputs to see what's the present value. So 3N, 10I, SKPV, $4,000 negative, PMT, 0FV, CPT, PV. So that's how you compute the present value, which gives you 10,942. Now you see, as I mentioned, the value of the present value of annuities due is greater than the present value of ordinary annuity. Since you discounted for one less period, actually this value is greater than the ordinary annuity by 1 plus I. What I mean by that, in other words, if you actually if you grow your money for one more period, you will receive, or you will reach that present value. So here I mean that the interest rate, in some texts we are using R or I, doesn't matter. In our case, that's 10%. The annual interest rate is 10%. So you are going to grow that 9,947.41 by 1.1. So in other words, you are growing that by 10%. Now do that. Plug this number in your calculators. Put these numbers in your calculator. See what you get. Is that same as 10,942? Maybe you were off by a few cents, which is fine because of rounding. But that's always true. The ordinary annuity is less than annuities due, or annuities due is greater than ordinary annuity. By how much? By 1 plus interest rate. Because again, you are discounted back for one less period. This is not only true for the present value, but also this is true for the future value. Why? Because actually for the future value, you are compounding for the future value, you're compounding for one more period. So when it comes to ordinary annuity, it's one less period. For the annuities due, you are compounding for one more period. So be careful with that. Now let's talk about perpetuities. Perpetuities are much more straightforward. Why? Because you're talking about the same payment forever. The formula is very easy. Just you need to divide the payment by the annual interest rate. So if you divide the annual or periodic payment on the interest rate, you will find the present value of perpetuities. Now, I'm going to talk about the specific form of perpetuities in which not only you receive the cash flow for unlimited period of time, but also these perpetuities are growing. This is kind of important, and the reason I'm having here is later when it comes to a stock valuation, we are going to deal with growing perpetuity. So it's very important to understand the formula for the present value of growing perpetuity. So that's the formula we use to calculate the present value of growing perpetuity. So that's your payment, your first payment. The R is your annual interest rate, and G, that's the gross rate. For example, your first payment is happening in this case, it's C dollars, whatever it is, 1 year from now. 2 years from now, it's going up by G%. So for example, if your first payment is, let's say, $10, that's your payment, and your G here in this case is, let's say, 10%. So your G, so let me write it down, is 10%. So the second payment will be $11 2 years from now, and so on and so forth. So that's example for the growing perpetuity. So let me plug the numbers here to find the present value of such perpetuity. So the first payment is $10 divided by Your annual interest rate, in this case, let's assume your R is 12%. So annual discount rate or interest rate is 12%. So that's 12% minus the growing rate is 10%. So that's $10 divided by 2%, which means the present value of the growing perpetuity is $500. Now, here you have to be careful. You're right. If the G is greater than R, you cannot use the formula. The assumption here is the interest rate is always greater than the gross rate of payment or the gross rate of equal cash flows or annual cash flow. Why? Because otherwise, if G is greater than R, the present value of growing perpetuity using this formula will be infinite and kind of a weird number. It will be negative, the denominator, and so it's kind of difficult to calculate that. So that's a major assumption. Otherwise, you have to use some other ways to find the present value of growing perpetuity. So that's it for today. Thank you very much. This is Ali, and that was the second lesson from the fifth module. We'll talk about other form of cash flows, and we'll wrap up our session in the next class. Take care, talk to you soon, and have a wonderful day.